Hey there, Algebra 2. Welcome to section 9.5, where we are going to look at the flip side of our series, which is the geometric series, where we're going to see a geometric sequence and add up all the terms in that sequence. So just a reminder, a geometric sequence is where we'll have the number of terms in our sequence will be multiplied by a common multiplier. So like if I had a 2, and then a 6, and then an 18, then a 54, that would represent a geometric sequence because it's multiplying by 3 to get to each new term. So to find the sum of the geometric series, we have a formula that goes along with that as well. And there's a couple different variations of the formula, but here's one variation of it. To find the sum of your number of terms, you can take your first term times 1 minus your common ratio to the number of terms in your series all over 1 minus your common ratio. And then what another variation of the formula is to find your sum. You can also distribute out that a sub 1. So you can do a sub 1 minus a sub 1 times r to the number of terms all over 1 minus r. So just a couple different variations of this formula to find the sum of your series. So here, if I have 4 terms, 1 through 4 here, this one would be, I'm just going to use this first one. This one would be the sum of 4 terms equals, I start out with a first term of 2 times 1 minus my rate, or my common ratio is 3 to the 4th power all over 1 minus 3. And just using a calculator to find that sum, I would just put those in and be able to find the sum of those 4 terms, which by hand, you'd get 70, or you get 80, but you'd be able to find that also using this formula. So let's try a couple. So we'll head on to our first problem. So what is the sum of this geometric series? So we're going to want to find basically 3 things. We want to know the first term, which there it is. So there's my first term. Know what the common multiplier is, which is 3. And then lastly, want to know how many terms there are. So I'll count those up. 1, 2, 3, 4, 5, 6, 7. So there's going to be a total of 7 total terms. Now I have enough. So I'm going to have a sum of 7 terms equals, let's see, we've got a 4 times 1 minus my rate, which is 3 to the 7th power, all over 1 minus 3. And for this one, I'll head to my calculator. We'll put 1 in here and check it out. All right, so in my calculator, I'm going to make a fraction. And then I'm going to put my formula, 1 minus 3 to the 7th. And close off those parentheses. And then down here, I'll just put 1 minus 3. And then we should get our sum, which is 4,372. So there would be our result using that formula. You could also distribute out the a sub 1 and use that formula as well. But there's going to be our result for answer 1. So heading to B, we're going to again pull out our number of terms, our first term, and then also our common ratio. So just kind of revisiting how the explicit form works. Your a sub 1 is going to be this first term, your starting term. And then this number that's being raised to your power, that's going to be your common ratio. So I have a common ratio of negative 1.5. Then I'm going to look for the number of terms. And this one is telling me to start at 0 and then go to 11, which is often thought of as 11 terms, but actually When you start at 0, that's an extra term. So we have 12 total terms here. So we're going to use 12 as our number of terms. So this will be sum of 12 terms is equal to first term, which is 3 times 1 minus. Now here's the first time we have a negative common ratio. We're going to make sure we put that into parentheses. So negative 1.5 to the 12th power. And then all over 1 minus negative 1.5. So make sure that we put that into parentheses so that we make sure that our calculator is taking the base of negative 1.5 and raising that to our power. But anyway, you put that in, you should get negative 154.50. And you will get possibly a little bit higher of a decimal, but we'll just round it to the nearest hundredth. So we'll get negative 154.50. And heading to C, just kind of the same idea. So here's our alternate formula. So we'll use this one this time. But here we'll have the sum of 10 terms. And it looks like we've got our first term, which is 19, minus, we've got our 19 again. Now our common multiplier, we're going positive, negative. So that tells me it's a negative, and it's negative 5. So I'm going to have a negative 5. And then raising that to the 10th power, all over 1 minus negative 5. So there's the alternate way that we can use this formula. But I'll go put that in my calculator and we'll get a result. So putting that in, I just use the alternate formula, distributing out that a sub 1, and we should get negative 30,924,476. So there's, kind of looking at all the different variations of how we can see these geometric series represented, and then how we can use a couple of different formulas to do that. And you can kind of choose which one you'd like to use. So you can pause the video right here and then check back with the now try to see how you're doing. So here we're looking at 7 terms. We've got a first term of 10, and then we've got a common multiplier of negative 6/5. So if you're ever unsure about what the common multiplier is, take the next term divided by the previous term. So I just took negative 12 divided by 10, which is going to simplify down to negative 6/5. So after calculating that, we'd get 20.83 for those 7 terms. So then there will be instances where we have a series, but we won't know. So we'll know the first term. We know it's multiplying by 4, but we won't know the number of terms. That's where we have to use the explicit form. So I don't know the number of terms. I need to figure out what is the term number of this last term. So I'm going to use the explicit form. So we got 49,152. And then that's going to equal my a sub 1, which is 3, times my common multiplier, which is 4. And then raise that to the n power. So I got to figure out what is the total number of terms in this series. And I'll raise it to that n minus 1 power. So then we got to do some algebra. So we're going to divide by 3 first. So that's going to give us then our 49,152 divided by 3, which will be 16,384 equals 4 to the n minus 1 power. Now here we got the n minus 1 up in our exponent, so we have to get that n minus 1 out of the exponent. Well, the only way to do that is to log both sides. So we're going to log 16,384, and then we're going to log the other side, which is going to bring that n minus 1 down in front, and then we're going to have log of 4. That's common log, so it is log of 4. And I shouldn't have had that there. But anyway, so now we're going to be able to solve this out. So I can now divide both sides by log of 4. Divide both sides by the log of 4. And now I have my algebra continuing. I'm still trying to figure out n minus 1. So I'm trying to figure out that number of terms here. So on the left side, I'm going to get 7 is equal to n minus 1, which add 1 over, I'm going to get 8 is equal to n. So there's going to be our number of terms in this series. Now I have the information I need. The sum of 8 terms is going to equal my first term, which is 3 minus 3 times, this is going to be a 4, because I'm multiplying by 4 to get to each term, to the n power, which should be 8. And divide that by 1 minus 4. So there would be your calculation then for finding the sum of that series. But that series, we didn't know how many terms there were. Another way you could do it is you could just take 48, and you could multiply by 4 and figure out that's 192, then multiply by 4 again, and continue, because usually there's not going to be too many terms, so you could just kind of multiply out to figure out the number of terms. Otherwise, you could use logs. That's going to always solve for your exponents. So go ahead and pause it here, and we'll figure out which term number is that 13,122. All right, so using the same method as before, we can use logs, and we figure out that the 13,122, that's going to be your 8th term, and then now you'd have enough to find the sum. So you'd have sum of 8 terms is equal to 6 minus 6 times 3 to the 8th power over 1 minus 3. So there's your result for the now try. So we can also look at geometric series in context. So here, Game Show is offering a price of 1 cent each day, and then 3 cents on the second day, 9 cents on the third day. What's the total amount of money earned in 2 weeks? So after 14 days. So we'd have our a sub 1, which is 1, minus 1 times, it's multiplying by 3, and then we're going to raise that to the 14th power over 1 minus 3. So we'll put that into our calculator. And we get 2,391,484, which seems like a lot, but remember this is in cents, so to change it to dollars, you'd move it over 2, and you'd get about $23,000, which still adds up pretty dang quickly. So you'd have $23,000 after 2 weeks. Here's a now try problem in context as well. So heading to our next problem, we've got a sum here that we're trying to find using the summation notation. So here I've got a total of 75 terms. I've got a A1 value of 90, and then I've also got my R right here. So to find the sum of this one, I would take the sum of 75 terms, because it goes 0 to 74, equals 90 minus 90 times my rate, which is 1.01, and then we're going to raise that to the 75th power, all over 1 minus 1.01. So we'll punch that into the calculator. And we get about 9,982, and it says round to the nearest integer, so we'll just leave it as that. So adding up those 75 terms, this one is not growing very fast. It's only growing by 100th each term. So we'd just be adding basically a bunch of 90s together, and we'd get 9,982. Lastly, we can look at infinite series. We can actually calculate it, but only if the geometric series converges. And it converges means that the R value, whether it's positive or negative, so absolute value, is less than 1. So that means that as the series goes on, your common multiplier is less than 1, so the numbers are going to keep getting smaller, which eventually you can add those because they're getting so small that they are going to have a limit. Geometric series that diverge, that would be when your R value is greater than 1. So they are going to increase as time goes on, so they will eventually approach infinity. So those you cannot calculate, they just are infinity, so they're infinite. But when you have a geometric series that converges, you can actually add the series up and find a limit. And one such series would be like if you just started with 1 and then you started adding half of each previous term. So you add 1/2, you add 1/4, you add 1/8, you keep on going in that general pattern. Eventually you will reach a limit. So if you think about it, I think of it like you're filling up 2 cups of water. Well, the first cup of water you're filling completely up. So that's what this 1 is representing. The second cup of water you're filling up halfway, which is representing this 1/2. Then you're filling it up a quarter. So now it's at about 3/4. Then you fill it up an eighth, which is another half of that. Then you're going to fill it up a 16th. And then you're going to fill it up a 32nd. But as you continue to cut that amount of water that you add in half, you keep just adding in to that cup only half its remaining space. So eventually it's going to limit out. It never fills up this second cup, so it approaches the number 2. And this is kind of where our formula comes from to find your sum of a geometric series. What you're going to do for these infinite series is you're simply going to take the first term, which is a sub 1, and divide it by 1 minus r. So like our case here, we had our first term was 1, and then we're dividing it by 1 minus 1/2, which is equal to 1 over 1/2, which half goes into 1 2 times. So when you think about this as in terms of water, you can fill up that first cup and then you fill up a half, a fourth, an eighth. You're never going to be able to fill up that second cup. You're always just going to approach 2. So 2 is going to be your sum for when you add up this infinite geometric series. So let's head into looking at these infinite series. So we'll head into this first problem. So we're first going to figure out, does it diverge or does it converge? So if it's diverging, I'm going to look for, converging, I'm going to make sure that r is less than 1. If it diverges, I'm looking to see if r is greater than 1. So here, this series, it's kind of hard to tell what's happening. So I'm going to take the -5/2 and divide it by 5. So -5/2 divided by -5. And this one is telling me that this one is an r value of 1/2. So it's going to have a convergent series. So this one I can actually calculate. I would take -5 divided by 1 minus 1/2. And as this one goes, then it's going to approach only a maximum of -10. So -10 is the max that it can approach. Heading to B, again, we got one that's kind of hard to tell. So we'll take the previous term and divide it by the next term. So we'll take 3/8 and then we'll divide that by 1/4, which we get an r value of -1.5. But since 1.5 is greater than 1, that's going to mean that one's going to diverge. And lastly, we've got a converge because it's going to be less than 1. So your r is less than 1. So here your first term is 1. It's hidden. It's not shown there, but then you'd have a 1 minus 0.8. So basically you're dividing 1 by 0.2 and you'd get 5. So there's your max sum of all those geometric terms. So heading into then our last example here. So here we're just kind of looking at the summation notation. So here this one starts at an a sub 1 of -3. But then here's your r value, and your r value is 5/4, which is greater than 1. So this one is right away, I can tell it's going to diverge. So it's not going to ever have terms getting smaller. So their terms are just going to get bigger, bigger, bigger. So it's eventually going to go to infinity. So we are going to say that one diverges. But we head to our delta math and grab that here. Head to our delta math, and we have a teacher-led problem. So we'll head to the class example here. So now looking at this one, so we've got a 2/5 that's happening right here, but the 2 is actually like in the numerator, so that would be your starting your starting point. So this one has a common multiplier of 1/5 as it goes. So 2 is your starting point, and then we're multiplying by a common multiplier of 1/5. So my common ratio is 1/5. Because 2 times 1/5 would give me that 2/5, but then 2 would represent that first term in my series. Then this one would be a convergent because your r is less than 1. So anytime your r is less than 1, it's going to converge, which you could find the sum for this one, which, I don't know, would be whatever 2 divided by 1/5 is, which is 10. So you could find out that that's going to eventually limit out at 10. But that does it for our lesson 9.5. So you've got the other side of our series, which is the multiplying, and a couple of formulas. You can use the formulas that Delta Math provides, or you have those on the back of your notes. But you can get to some practice and go ahead, get started. Good luck, and we'll see you next time.